So this video is about exponential equations. The idea is to take logarithm on both sides upon simplification. So here are a couple of examples. Example 1. Solve for x. E raised 5x minus 5 times e raised negative 3x equals 4e. Now, since the bases are identical, you can combine the powers and you could write it as 5x minus 5 plus of minus 3x equals 4e. Now, simplifying the power, we'll have 2x minus 5 in the power equals 4e. Since we have e on both sides, we divide by e on both sides. So dividing both sides by e, we will have 4e over e on the right hand side, and the e's will get cancelled. Now, moving the e to the numerator, you will get 2x minus 5 minus 1 equals 4. Now, since it is base e on the left hand side, you can take logarithm on both sides to solve for x. Now, you have to take natural logarithm on both sides. Natural logarithm on both sides. You will get natural logarithm of e raised to x minus 6 equals natural logarithm of 4. 2x minus 6 in the power will come out, leaving ln of e equals ln of 4. But ln of e is nothing but log e base e, and log e base e is just 1. So 2x minus 6 will be equal to ln of 4. 2x will be equal to ln of 4 plus 6. X will be equal to 6 over 2 plus ln of 4 over 2. I'm dividing both sides by 2. So I'll get 3 plus 1/2 ln of 4. Now I could use power rule and move the half inside. I'll end up getting 3 plus raised 1/2, which is nothing but 2. So the answer would be 3 plus ln of 2. You may leave the answer as is, or you can convert it to a decimal using your calculator. ln of 2 can be readily found using your calculator. Now, example 2. The equation is 3 raised x minus 5 equals 7 raised 2x plus 1. And we have to solve for x. You may select either side to find a solution. But if you take the left hand side, you have to take log base 3 on both sides. If you want to take the right hand side, you have to take log base 7 on both sides. So I'm going to use the left hand side, so I'll take log base 3 on both sides. And I could use the power rule and move x minus 5 out of the logarithm. That leaves me with log base 3 of 3, which is equal to power rule again, 2x plus 1 times log base 3 of 7. Log base 3 of 3 is just 1. So x minus 5 would be equal to 2x plus 1 times log base 3 of 7. So we can move the 5 to the other side. So x would be equal to 5, and distribute, and get 2x times log base 3 of 7 plus log base 3 of 7. Now move the x's to one side, we will get x minus 2x log base 3 of 7 equals 5 plus log base 3 of 7. Have x's in common, so we can actually pull the x out on the left hand side. That would give us x times 1 minus 2 log base 3 of 7 equals 5 plus log base 3 of 7. Divide both sides by the term, you will get x is equal to 5 plus log base 3 of 7 over 1 minus 2 log base 3 of 7. The denominator, I could rewrite it as 1 minus log base 3 of 49 using power rule, which 7 base 2, which should be 49. You may leave the answer as is, or you could convert it to decimals. You can recall log base 3 of 7 is nothing but log 7 with log 3. Likewise, log base 3 of 49 is log 49 over log 3, both of which can be calculated using a calculator. Go to example 3. I have to solve for x, and the equation that we have here is 5 raised to x plus 3 times 5 raised to 3x equals 39. You may see that there is a 5 raised to x in both terms, and you could pull it out. You could write it as 5 raised to x times 1 plus 3 times 5 raised to x equals 39. But even after doing that, we cannot solve this equation. It's just not possible. Even if you take logarithms, it's not possible. So, technically speaking, the problem will not have a solution. Therefore, we do not have a solution. Of course, numerically you could find a solution, but manually we cannot find a solution. But if I changed the second expression, 5 raised 3x, to 5 raised 2x in the question as follows, then I have a 5 raised to x common in both terms, which I can pull out, leaving 1 plus 3 inside and 39 on the other side. So 5 raised to x times 4 would be equal to 39. Divide by 4 on both sides, you will get 5 raised to x equals 39 over 4. Now, since you see a 5, we have to take log base 5 on both sides. And that should be log base 5. Now, using power rule, the 2x would come out, leaving log base 5 of 5 equals log base 5 of 39 over 4. Log base 5 of 5 is 1 again. So 2x would be equal to log base 5 of 39 over 4. Divided by 2 on both sides, we will get log base 5 of 39 over 4 divided by 2. You may leave the answer as is, or you could convert it to a decimal. Here is problem 4. We are solving for x again. 6 raised x plus 1 equals 4 raised to x minus 3. Now, we can either start with the left hand side or the right hand side. If we start with the left hand side, we have to take log base 6 on both sides. If you start with the right hand side, you take log base 4 on both sides. But regardless of what side you choose, the answer will be the same. Let's start with the left hand side and take log base 6 on both sides. Using power rule, the x plus 1 would come out, leaving log base 6 of 6. The same applies on the other side. Log base 6 of 4. That is just 1 log base 6 of 6. So x plus 1 would be equal to distribute 2x log base 6 of 4 minus 3 log base 6 of 4. Move all the x's to one side, numbers to the other. I'll have x minus 2x log base 6 of 4 equals minus 1 minus 3 log base 6 of 4. You have an x in common on the left hand side. You can pull that out. I have 1 minus 2 log base 6 of 4 equals minus 3 log base 6 of 4 minus 1. Divide by the term 1 minus 2 log base 6 of 4 on both sides. We'll end up getting minus 3 log base 6 of 4 minus 1 divided by 1 minus 2 log base 6 of 4. Now x would be equal to log base 6 negative 4 raised 3 using power rule. Use power rule again, you'd have log base 6 of 4 squared in the denominator. That will give us minus log base 6 of 64 minus 1 divided by 1 minus log base 6 of 16. You may leave it as is or use your calculator and change the base formula and find the answer in decimal form. This is the last problem. Slightly different. It requires a few tricks. So we're solving for x again. So the equation is e raised to x minus 6 e raised x plus 8 equals 0. Now clearly the first term is exactly the power of the first term is twice the power of the second term, e raised x. So we could use a substitution. We could just say that u is e raised x, and we could rewrite the original equation as e raised 2x or e raised x squared minus 6 e raised x plus 8 equals 0. Now replace e raised x by u squared minus 6u plus 8 equals 0. And that is a quadratic equation. You may either use the quadratic formula or factor. This is factorable, so let's go ahead and factor it. U minus 4 times u minus 2 equals 0. So the solutions for u are u equals 4 and u equals 2. But we're not looking for a solution for u, we're looking for a solution for x. So we've got to change u, replace u by e raised x. So we get e raised x equals 4 and e raised x equals 2. Now those are exponential equations. So I see e, so I've got to take natural logarithm of e on both sides. And using power rule, the x would come out. X times natural logarithm of e would be equal to natural logarithm of 4. Likewise, x times natural logarithm of e is equal to natural logarithm of 2. But natural logarithm of e is just 1. So both the terms would become 1, and we'll have x is equal to natural logarithm of 4 and x is equal to natural logarithm of 2 as our solutions. I hope you can follow exponential equations now. Thank you for watching this video.